Okay, ma? See this circuit. So there are 3 resistors, 8R, 12R, 24R. We are supposed to find out equivalent resistance between A and B. Now see, ma. So 2 point A, 8R is connected, no? So listen carefully, ma, how we analyze this one. 2 point A, 8R is connected. And from point A, we have one connecting wire also, which connects 12R and 24R. Okay? It means that here if potential is VA, here also potential is VA only, no? Because in between these 2 points, there is no resistor. Are you able to understand, ma? So this point and this point, they are equipotential points. So to equipotential point, how many resistors are connected? 1 resistor, 2 resistor, 3 resistor. Are you able to understand, ma? So VA to VA, 3 resistors are connected, no? One side of 3 resistors. But if you take this point here, see, this point I can say it is at a potential as VB, no, ma? So to VB, how many resistors are connected? This resistor on this side, it is connected to VB. Similarly, if you come here, these 2 resistors are also on the second side, they are connected to VB. That's all, no? So if you take this resistor, one connected, one potential at VA, second potential VB. Similarly, if you take this resistor, one VA, second one is VB. Similarly, this resistor, one is VA, second one is VB. So what do you understand? All of them, they are connected in parallel connection. So if they are connected in parallel connection, then only all the resistors on one side, they will be at one potential. On the second side, they will be at a different potential. That's all, no, ma? Are you able to understand? See, ma, here what is the potential? Here potential is VA. It means first resistor, second resistor, third resistor. On one side, they are connected to VA. On the second side, they are connected to VB. Satisfied, no? It is possible only when they are connected in parallel connection. So therefore, what are the values which are given? 8R, 12R, 24R. So how can I calculate equivalent resistance, ma? 1 by 8R plus 1 by 12R plus 1 by 24R. LCM I can take 24R. Okay, ma? So 3R plus 2R plus, no need of R again. So 3 plus 2 plus 1. Okay? So therefore, what is the equivalent resistance? R equivalent is equals to 24R divided by 6. 6 4s are. So 4R is the equivalent resistance. That is our answer. Okay. So let us see this question. So this is the given circuit, ma. See, ma, here there is no symmetry first of all. Why? This is 2, 4, 8, 6. 3 and 6. Resistors are not equal. So upper half, lower half, they are not equal. Right side and left side also, they are not equal. So this is not a question based on symmetry. This is not Wheatstone bridge also. So there is no concept of equipotential points also. Just we have to redraw the circuit, that's it. Okay, ma? Now see here. This is point A. Okay, ma? If this is point A, this is also point A only, no? This is also point A only, no? Why? There is no resistor which is connected. So here if potential is VA, here also VA, here also VA, everywhere same VA only. It means this branch is connected to VA. This branch also connected to VA. 3 ohms is connected to VA. 6 ohms is also connected to VA. All of them, they are connected to VB. Are you able to understand? It means this branch, this branch, this branch, this branch, every branch, they are in parallel connection. Are you able to understand? And how to redraw this one into parallel connection, let us see. Now one more point which we should understand is, here resistors are connected also. Clear, no? So therefore, how I can redraw this circuit is, so this is 3 ohms resistor and this is 6 ohms resistor. Okay, ma? And from A, 2 and 8. 2 and 8, they are connected like this. And they have a common point, and from here again 6 and 4, they are connected like this. Are you able to understand, ma? All of them, they are connected to what? All of them, they are connected to point B. This is the circuit which I can draw. So 2, 8, 6, 4. This is the diagram. Are you able to understand? Are you able to understand, ma? 2, 8. Definitely they are in parallel connection, no? Because current gets divided here. Okay, and this 6 and 4 also, they are connected in parallel connection. and all of them, they are joined also. It means these two resistors, they are joined. Are you able to understand? So now just simplify this circuit, then you will get the answer. Clear, Nama? Now can you simplify it? So simplify it and check what is the answer you will get. Okay, ma? So if I do the calculation, 2 and 8, they are connected in parallel connection, no? So 8 into 2 by 8 plus 2. So 16 divided by 10. Okay, ma? So I will divide by 2, 8 by 5. 8 by 5. 6 and 4, they are also connected in parallel. So 6 into 4 by 6 plus 4. Huh? How much, ma? Total resistance. So 6 into 4 divided by 10. So it is 24 by 10. Okay, ma? So 24 by 10 means 12 by 5. Okay? So this is 8 by 5, this is 12 by 5. So if you add both of them, 5 is common, denominator is common, no, ma? So 8 plus 12 is 20 by 5. 20 by 5 is 4. So this is 4 ohms resistor. Okay, ma? Now 3, 4 and 6, they are connected in parallel connection. So therefore, 4 by 9 by 12. Malli divide cheyandi, 4 by 3. 4 by 3 is correct. Reciprocal no, 12 by 9. Okay. So therefore 1 by R is equals to 1 by R1 plus 1 by R2 plus 1 by R3. Okay. So 1 by 3 plus 1 by 4 plus 1 by 6. LCM I can take 6. Okay, ma? So it is 2 plus, LCM is not 6, 12. 12. So 4 plus 3 plus 2. Okay. So how much? 9 by 12. So therefore R value is how much? 12 by 9, which is equal to 4 by 3 ohms. That is my answer. Fine? That's it. Okay. So see this concept where 3 resistors are connected in series. Values are R1, R2 and R3. Okay. What is the total supply potential we are giving? Total supply potential is V. Understood, no? చెప్పేటప్పుడు బుద్ధి ఉండేవాడు ఎవడు రాయడయా? ఏం చేస్తూ ఉన్నారు మీరు? ఓకే. సో టోటల్ సప్లై పొటెన్షియల్ ఈస్ V. So this supply potential is divided in all the 3 resistors. What is meant by potential? Already we have studied, Nama, work done per unit charge. So out of the total capacity of the battery, first resistor will take V1 potential, second one will take V2 and third one will take V3. Resistances are R1, R2 and R3. Clear? Then how can I calculate total current flowing in the circuit? Ohm's law is there, no? I is equal to V by R. And because they are connected in series connection, equivalent resistance is how much? R1 plus R2 plus R3. Okay, ma? Then in this condition, if I want to calculate a potential difference across first resistor, similarly V2 is the potential difference across second resistor, V3 is the potential difference across third resistor, then these are the shortcut formulas which we can use. Okay, ma? If you can use these formulae without any tension, without wasting time, very easily you can calculate the resistances. If 3 resistances are present in series, if only 2 are present, then here instead of R1 plus R2 plus R3, I will write just R1 R2. Here also R1 R2, here also R1 R2. Are you able to understand, ma? So V1 is equals to VR1. What is R1? Resistance of the first resistor. And V1 is also potential difference across the first resistor. So VR1 divided by R1 plus R2 plus R3. Similarly, this formula also. Is it clear? Right. Shortcut formula. Okay, ma? So see this question, ma. So here, this is VI graph, ma. On x-axis what we have? On x-axis we have potential, no? On y-axis we have current. Clear, no, ma? So with respect to this VI characteristics, there are 3 graphs. First graph, second graph and third graph. What does they represent? 2 resistors and their series combination also. It means one graph represents what? R1. Clear, number? One resistor. Second graph represents what? It represents resistance R2. Third graph represents? Chapande. Third graph represents their series combination. No, it means R1 plus R2. That's all, number. So out of these 3 graphs, one is the graph of R1, One is the graph of R2 and another graph is the graph of R1 plus R2. For series combination, this is the formula, no? R1 plus R2. Now can you say which graph belongs to this series combination? First graph, second graph, or third graph? Anybody? Which graph represents R1 plus R2? Third graph. This one. How can you say? Sima. R is equals to V by I, no? R is equals to V by. This relation we know, no? According to Ohm's law, R is equal to V by I. So therefore, for example, on y-axis I is given, on x-axis V is given. Let us take this graph. Okay. So if you see what is the format of this equation, R is equal to V by I, ఏ formula ఉంది ఇది చెప్పండి? Is it in the form of multiplication or is it in the form of division? Division form lo undi kada. What do you understand by division form? If any equation is present in division form, what you should understand immediately? Slope of this graph will give resistance. That's what we have studied, no? ఇప్పటికే 130 సార్లు చెప్పినాయి, 131 సారి. If any equation is present in the form of a division, then you take the slope of that graph. Slope gives the value which is present on the left hand side. Are you able to understand? So therefore, how to take the slope of this graph? I can take slope like this, no? This is how I take the slope. This is the slope. Are you able to understand? And if this slope, if I divide into two parts, what is this one? This is a di, no? Change in current. Di, no? What is this one? dV, change in potential. Are you able to understand? So this much part belongs to change in current, this much part belongs to change in voltage. What I am doing, I am splitting this slope into two components. Are you able to understand? Now if you take R value, how can I write R value? I have to write dV divided by di. That's all, no? dV divided by di. So R1, R2 is a big value, no? In series combination, if you do R1 plus R2, what happens to total resistance? Total resistance increases. If total resistance should increase, then in this graph, dV should be bigger, di should be smaller. That is the meaning of this one, no? So for R to be bigger, R పెద్ద value ga undali ante numerator should be bigger, denominator should be smaller, then automatically R value will be bigger. Now this condition is satisfied in which graph? First graph, second graph, or third graph? Third graph. బాగా ఆలోచించండి. Okay, Sima. In this graph, if I take a small value of di, okay ma? Let di value is same in all the three graphs. Okay? So let this much of di I will take. Di means change in current. So here also I will take this much amount of di, same amount of di. And in the third graph also I will take small amount of di. Okay? For this di, in the first graph, I will get this much of dV. Clear, no? In the second graph, I will get this much of dV. And in the first graph, I will get only this much of dV. So dV should be maximum, no? dV is maximum in which graph? That is my answer. అర్థమైంది ఎలా చేస్తా ఉన్నాము? Clear, no? So therefore, for same di, dV is maximum in which graph? dV is maximum in first graph. Okay, ma? Therefore, first graph is the graph of series combination. That is my answer. Are you able to understand? That's all. So logical thinking is very important. Okay, Sima. So this is the given circuit, ma. So these are the resistors which are arranged. Now I want to calculate equivalent resistance between A and B. Can anybody say how can I solve this one? How can I find out equivalent resistance between A and B? Any idea? Nobody? See, here C and D. In between these 2 points there is no resistor, no? In between C and D there is no resistor. So therefore potential at point C will be equal to potential at point D. Can I say this point? What is the potential existing at point C? Same potential will be existing at point D also. Are you able to understand? So if there is no resistor between equipotential points, then current prefers to travel in this short circuit path only. This point you can call it a short circuit point also. It means a current will bypass these two resistors. Are you able to understand? Let us call it as resistor number 1, resistor number 2. So as there is a short circuit, between C and D, total current prefers short circuit path. And resistors 1 and 2 are bypassed. What is meant by bypassed, ma? Bypassed in the sense current doesn't enter into those resistors. Okay. So therefore, what is the equivalent circuit I can draw? Equivalent circuit is like this. This is my equivalent circuit. Clear, no? This is terminal A and this is terminal B. So this is resistance R, this is also resistance R, this is point C and this is point D. Okay. Now can you say what is the equivalent circuit? R and R, they are connected in series connection. So therefore my equivalent circuit is this much. Clear, no? So A, B, R, R. So therefore it is 2R. This is the equivalent resistance between A and B. That's all. Clear, no, ma? This is one method in which we can understand this one. Okay? Make a note first of all. Same problem, Sima. In one more method, how I can do this one is clear. See, these 2 points, they are equipotential points, no, ma? So therefore, what I can do is I can join these equipotential points also, ma. Okay? Second method of solving is join the equipotential points. Okay. We can just join these equipotential points because both points are at the same potential. No? If you join them, nothing will happen. Okay. So therefore, how circuit will change? Circuit will change like this. Okay, ma? And because we are joining these 2 points, so here there is one resistor, here there is one more resistor. Okay, ma? This is first resistor and this is second resistor. I can draw like this also. No? So just I am joining C and D. So R and R, these are the 2 resistors. And above these points also we have 2 resistors. No, ma? These are the 2 resistors. Okay. And whenever you get this type of circuit, current never enters into a loop. You can understand like this also. Ikkada oka loop form ayindi kada. There is a loop which is formed and current never enters into loops. Understood? No? So like this also you can solve. Then also if you remove this loop, R and R, they are connected in series connection. No? So 2R is my equivalent circuit. Clear? So therefore what I say here, so resistors 1 and 2 are in a loop. Okay, and current never enters a loop. So therefore you can remove the loop and again the equivalent resistance will become 2R. Okay, that's it. Understood, no? Different techniques of understanding the same problem. Like this. That's it. Okay. Okay, ma? So what we have done? No. See, ma, previously circuit was like this, no? So in traveling to this point, number of resistors are same from point A and point B. Okay, so therefore we can disconnect this circuit like this. Okay ma? Now everything has converted into series and parallel combination of resistors. So therefore do the calculation now. So these two resistors, they are in series, no? So instead of these two, I will write a single resistor of resistance R. Clear, no ma? Now similarly these two resistors, 2R, no? These two resistors are also there in series. So again I will write a single resistor of resistance 2R. Clear? And same concept can be followed on this side also. And 2R and 2R, they are in parallel connection, no ma? So 2R by 2 is how much? R. So again instead of these two resistors, I can write a single resistor of resistor R. Okay? Similarly on this side also, I can write a single resistor of resistance R. Is it clear? Now see. So this is also R, this is also R, this is also R, this is also R, this is also R. Now 3R and 3R, they are connected in series. So here there is R and R. So 3R, 2R and 3R, they are connected in which connection? Parallel connection. So therefore do the equivalent resistance 1 by 2R plus 1 by 3R plus 1 by 3R. Have you understood ma? LCM I can take 6R. So 3 plus 2 plus 2. Correct only na? 3, 2, 2. So therefore 1 by R equivalent is how much? 5, 7 by 6R. So therefore equivalent resistance is 6R divided by 7. That is my answer. Understood no ma? That's it. See, I will do the calculation. So this is the given circuit, and these are points A and D, and these are points B and C. Okay, ma? So I want to calculate equivalent resistance between these 2 points as well as these 2 points. Okay. First of all, we will calculate this one, ma, equivalent resistance between points A and D. Okay. What is meant by points A and D? Battery connection is given between these 2 terminals. That is the meaning of this one. No? Battery connection is present between A and D. Okay. Now see. So actually, this is the direction in which current flows, no ma? If this is the equivalent resistance, current initially enters A. Finally, it enters into D. So this is the direction in which current flows. So definitely current flows through all these resistors. But initial point is A, final point is D. So finally current should be flowing from A to D, in whichever path it is possible. Okay. So therefore, if I draw this kind of line, is there any symmetry across right hand side and left hand side? Definitely there is some symmetry, no? So what is the circuit existing on the right hand side? Same circuit is present on the left hand side also. So therefore, what kind of symmetrical line is it? Is it parallelly symmetrical or perpendicularly symmetrical? Perpendicular symmetry. Current is traveling from A to D, no? My line is also in the same direction. This is parallel symmetry. Parallel symmetry. Okay, ma? Current is flowing like this. If I draw a line like this, then this is perpendicular symmetry. In capacitors already we have studied now. Same concept once again I am explaining here. If you forget the rules, go to capacitance. Okay? And in symmetry concepts are there no in capacitance, so see them once again. Okay? So therefore, this line is what? This line is parallel axis symmetry. Parallel axis of symmetry. Because this line is in which direction? It is in the direction of current flow itself. Current starts from A, finally reaches D. Clear, no ma? So this is my parallel axis of symmetry. And what is the importance of parallel axis of symmetry, ma? In capacitance, what we have studied. Okay. So in parallel axis of symmetry, if you see the points which are on either side of this parallel line of symmetry, then those 2 points will be equipotential points. Clear, no? For example, if I name this point as point X, if I name this point as point Y. Okay. Similarly, this point is point B and this point is point C. So what is the positioning of X and Y, ma? They are arranged symmetrically to this parallel line, no? Similarly, what is the positioning of B and C? They are also arranged symmetrically to this parallel line of symmetry. Okay. So therefore, what I say that potential at point X must be equal to potential at point B. Okay. Similarly, potential at point B is equals to potential at point C. Why these points are potential? That is the property of parallel line of symmetry. So if you see any points which are symmetrical across the parallel line, across means on either side of parallel line, then those 2 points must be at the same potential. So X and Y are at same potential. Similarly, B and C also, they are at same potential. Understood, Nama? So if they are at same potential, then what I can do? Equipotential points బాగానే ఉంది అంతవరకు తర్వాత ఏం చేయాలి? Sima, if there is a resistor between equipotential points, current cannot flow. Already we have studied, no? If there is no resistor, then current might flow, might not flow. But if there is resistor and these 2 points are equipotential, then current can never flow. Okay? So if current doesn't flow, then what is the use of these 2 resistors? There is no use of these 2 resistors. Are you able to understand? So I can remove this resistor. Between equipotential points, if there is a resistor, current doesn't flow. So better make a note of this point. Okay? What is the note point I have to write? If there is a resistor, between equipotential points, then current does not flow. Okay? If current does not flow, you need not place those resistors. You can remove those resistors. Okay? Now, Sima. So, the current which enters at point A, it divides into 3 branches, no? First branch, second branch and third branch. So, this total current enters again here. This current enters here. And some current reaches directly from A to D. So, it means that this branch and this branch, they are in parallel connection. No? Are you able to understand? Ma? This is the battery connection. No? Battery connection చూసుకోవాలి first మీరు. So current I enters like this. So out of this total current, some I1 enters into this branch, I2 enters into this branch, I3 enters into this branch. And all these currents again, they will reach point D. So like this, I1 will enter and reach here. So I3 will enter and reach here. I2 will enter and reach here. It means first branch, second branch, third branch, all the branches, they are connected in parallel connection. So draw the parallel connection. So consider this is point A. Consider this is point D. Okay, ma? If you take this branch, 1, 2, 3, 3 resistors are connected in series. Clear, no? And from A to D, directly there is one single resistor. And if you travel in this branch, again 1, 2, 3, 3 resistors, they are connected in series. That's all. This is my equivalent resistance. Understood, no? So therefore, 3R and R, they are connected in parallel connection. So what is the equivalent resistance, ma? It is 1 by R plus 1 by 3R plus 1 by 3R. 3R if I take the LCM, okay, ma? 3 plus 1 plus 1. So equivalent resistance is 3R divided by 5. That is my answer. Understood, no? That is the equivalent resistance between which points? A and D. Okay. Now we will calculate equivalent resistance between B and C also. Have you understood, ma, how we are solving? Very simple. Anybody? So now in the same circuit, what we are supposed to find out equivalent resistance between B and C. Okay, ma? So what is the meaning of this one? It means battery connection is present between B and C like this. Consider this is the battery connection. So current enters from here. Finally current reaches point C. Okay, ma? Now if I draw this line, previously also I have drawn the same line, no? Now also I am drawing the same line, this line. But now this line, will it become parallel axis or perpendicular axis? This will become perpendicular axis. Why? Current enters into B, finally reaches into C. This is the current direction. This is the current direction, no? Meanwhile, it enters into different branches. That is a different condition. Basically, it starts from B. It reaches up to C. That's all, no? So, therefore, as current is flowing in this direction, this line is perpendicular to the what you call current direction. So, this one I can call perpendicular axis of symmetry. Understood, no? Perpendicular axis of symmetry. Now, what is the importance of perpendicular axis of symmetry? Whatever points you find on perpendicular axis of symmetry, they are equipotential. Clear, no? Now, see, right of the circuit and left hand side of the circuit, they are symmetrical, no? So, which points are present on this perpendicular axis symmetry? Point A and point D. Both of them, they are present on perpendicular axis, no? So, definitely I can say potential at point A must be equal to potential at point D. Clear nama? Why? Because these points, they are present on the perpendicular axis of symmetry, and whatever points are present on perpendicular axis, they must be equipotential points. Okay, if you want to make a note of this point again. Okay ma? If there are points on perpendicular axis of symmetry, then those points are equipotential points. Those points are equipotential points. Okay ma? So point A and point T, definitely they are equipotential points. If they are equipotential points, what I can do? Remove this resistor. There is no use of this resistor, no ma? Because these two are equipotential, and if there is a resistor, current never enters that branch. Now see. Now everything has converted into series and parallel connection, no? See this branch, R and R, 2R. Similarly, this branch, R and R, 2R. To this R, this branch and this branch, they are in parallel. Now here I will get a single branch. So this branch, and this branch, all of them, they are in parallel connection. So just solve it. Clear nama? So instead of this one, I can write this is equals to 2R, and this is R. Okay? So therefore what I will do, 2R into R divided by 2R plus R, because they are in parallel. So 2R into R by 3R. Okay ma? R gets cancelled. 2R divided by 3. Okay? So therefore instead of these two resistors, I will write a single resistor whose resistance is how much? Whose resistance is 2R divided by 3. Clear no? Now again R, 2R by 3 and R, they are connected in series connection. So solve them also. So R plus 2R by 3 plus R. How much ma? 4R plus 2R, 4R or 3R? 3R plus 2R plus 3R by 3. So total how much? 8R. 8R divided by 3. Okay? So therefore instead of these three resistors, I can write a single resistor of resistance. How much? 8R divided by 3. And here also instead of these two resistors, I can write a single resistor of resistance 2R. Clear no? Now which resistors are in parallel? 2R, 8R by 3 and R. They are connected in parallel connection. Clear? So therefore what is the equivalent resistance? 1 by R equivalent is equals to 1 by 2R plus 3 by 8R plus 1 by R. So for all of them I can take R, 8R to be my LCM. Then it is 4 plus 3 plus 8. So total how much ma? It is 12, 15. 15 by 8R. So therefore what is the equivalent resistance? Equivalent resistance is 8R divided by 15. That is my answer. Understood no ma? That is how we can do the calculation. Correct. So Sima. So this is the given circuit. Now symmetry is present along which axis ma? Symmetry is present along parallel axis also. Symmetry is present along perpendicular axis also. Okay? But even though there is symmetry along parallel axis, there is nothing you can do. But if you see perpendicular axis of symmetry, if you see, if you name these points as point X, point Y, point Z. Clear no ma? X, Y, Z points, they are present on perpendicular axis, no? ఈ మూడు పాయింట్స్ దేనిపైన ఉన్నాయి? Perpendicular axis. It means point X, point Y, point Z, they are equipotential points. Ante kada? Okay ma? So therefore, X, comma, Y and Z, where they are present on where? Perpendicular axis. So therefore what I can write, potential at X is equals to potential at Y is equal to potential at Z. So you can, if they are equipotential points, what you can do, just remove these resistors. No use of resistors, no, current will not enter into them. Now first branch, second branch, third branch, they are series connection. So 2R, 2R, 2R. So 3 2Rs are present in parallel, no, so equivalent resistance is 1 by third of 2R. So point A, this is point B. This is my answer. Sima, 2R branches, 3 branches are there, no? So equivalent resistance, just divide by 3. Like this also you can do, without any calculation. Okay? If 2 resistors are 2 branches are there, 2R by 2. 3 branches are there, 2R by 3. 4 branches are there, 2R by 4. Like this you can divide in parallel connection. Okay? That's it. So this is the given circuit. We are supposed to find out equivalent resistance. Okay? Correct. So there is parallel symmetry also, there is perpendicular symmetry also, and there is path symmetry also. Path symmetry is also there, no? So in reaching to this point, from either point A or point B, you have to cross same number of resistors. If you travel like this, 1 resistor. If you travel like this also, 1 resistor. So like this if you travel 2 resistors, like this if you travel 2 resistors. Then already we studied that this circuit can be disconnected, no, if there is path symmetry. So you can disconnect the circuit like this. Clear, no? So each resistor is R. So 2R and R, they are connected in parallel connection. So 2R into R divided by 2R plus R. Okay? So 2R into R divided by 3R. So 2R by 3. So therefore instead of this total branches, I can write a single resistor of resistance 2R by 3. Similarly here also I can write a single resistor of resistance 2R by 3. Now R and R, they are connected in series connection, so I can write a single resistor of resistance 2R. So this is R, this is R, this is R, and this is also R. Okay? So 2R by 3 plus 2R. Okay? So 2R by 3 plus 2R is how much? 2, 6 to 8R by 3. Okay? So therefore, instead of all this branch, I can write a single resistor whose resistance is equals to 8R by 3. Clear, number? Similarly, here also I can write a single resistor of resistance 8R by 3. Clear, no? Now if you see here 8R by 3, 2R and 8R by 3, they are connected in parallel connection. So therefore, what is the total equivalent resistance? You take the reciprocal, 3 by 8R plus 3 by 8R plus 1 by 2R. Okay, ma? So 8R I can take LCM. Therefore, 3 plus 3 plus 4. So equivalent resistance is how much? 8R divided by 7, 10. So it is 4R divided by 5. That is our answer. Clear, no?